The main problem involving space and time in the physics of very small things is that our notion or idea of movement we lose when it is very tiny. No longer being observable or detectable, we lose the meanings of time and space. We lose the definitions that we make of them for us. As by the continuity and extension of empty space, every movement and always also a perfect rest does not make sense to admit that there exists in the universe an absolute minimum standard amount of movement called time, because time is always a relative measure having no absolute existence. What exists are minimal perceptible amounts of time for us. Admitting that there is an absolute minimum unit of time, an indivisible grain of time, does not correspond to the reality that we verify. The same reasoning is valid for space, since time only exists because space exists. Time is a comparison of movements through space. A standard movement through space allowed by the continuity and extension of empty space that allow the existence of movements along the way make them physically completely equivalent to rest. Because empty space is continuous, any region of space is the same as any other region. There is no separation or division between them, which makes rest completely equivalent to motion physically. For physics, every motion situation is always perfectly equivalent to the resting situation. Imagine a small visible dot in space. If this point is very small, so small that its size does not reach any important measure on our ruler, we say that the point is almost dimensionless. Now imagine that this point that we define to be almost dimensionless moves, oscillates in the same direction from left to right and vice versa back and forth. By observing this oscillatory movement of the point in the same direction, if this movement is relatively fast, we form the idea from one line. We visualize what we call being a spatial dimension. If we notice that this line also moves, it oscillates at a 90-degree angle in relation to the original movement of the point up and down, we can visualize a plan, forming the idea what we call being two spatial dimensions. If we also notice that this plane also moves, it oscillates at a 90-degree angle in relation to the movement of the line back and forth. If these movements are relatively fast, we can visualize the geometric figure that we call a cube. We form the idea of what we call three spatial dimensions. If this cube also oscillates relatively quickly, increasing and decreasing in size in all directions, doubling in size and returning to the original size, we can visualize the concept that we call a hypercube. This would be a cube endowed with four spatial dimensions, while we always say that space has only three dimensions. Movements have the ability to create the concept that we call dimensions. Time itself, which is also movement, is also a dimension. A world made of copies. Can an exact replica, a perfect copy, be identified, named, considered, and treated as if it were the original? In an eternal universe where everything is repeated all the time, there are no originals. Copies only exist because there has always been another copy, just like the one before the so-called original. The difficulty in getting perfect copies made artificially resides simply in the complexity of the attempt and not in its physical impossibility. There is no physical impediment to obtaining a perfect copy of any physical object. The universe, which is eternal, finds no difficulty in making perfect copies of anything. So, about the existence of perfect copies, quantum physics gives us very precise information. According to quantum mechanics, every electron in the universe is identical to all the others. They all have exactly the same mass, exactly the same electrical charge, the same properties of the strong and weak nuclear forces, and the same total spin. The well-tested description given by quantum mechanics says that these qualities are the only ones an electron can have. Electrons are all identical with respect to these properties, and there are no other properties to consider.